History of Electronical Engineering by David Puerta Lotero. The history of electronics is a story of the 20th century and three key components: the vacuum tube, the transistor, and the integrated circuit. In 1883, Thomas Alva Edison discovered that electrons will flow from one metal conductor to another through the vacuum. This discovery of conduction becomes known as the Edison effect. In 1896, the first application of electron tubes were in radio communication. Guglielmo Marconi pioneered the development of the wireless telegraph in 1895-96 and long-distance radio communication in 1901. In 1904, John Fleming applied the Edison effect in inventions and two-element electron tube called a diode. In 1906, and Lee D. Forrest followed in three-element tube, the triode. These vacuum tubes were the device that made manipulation of electrical energy possible so it could be amplified and transmitted. The early radio consists of either radio telegraphy, the transmissions of Morse code signal, or radio telephony, voice message. Both relied on the triode and made rapid advance thanks to armed force communication during World War I. Early radio transmitters, telephones, and telegraph used high-voltage sparks to make waves and sounds. Vacuum tubes strengthened weak audio signals and allowed the signals to be superimposed on radio waves. Edwin Armstrong in 1918 invented the super heterodyne receiver that could select among radio signals or stations and could select among those signals. Radio broadcasting grew astronomically in the 1920s as a direct result. Armstrong also invented wideband frequency modulation, more called like FM. In 1920, radio is the primary form of education and entertainment, was soon called by television, which was invented in the 1920s, but didn't come widely available until 1947. In 1927, Bell Laboratories publicly unveiled the television in 1927, and its first form were electromagnetica, when an electronic system was proved superior. Bell Labs engineers introduced the cathode ray picture tube and color television, but Vladimir Zworykin, an engineer with the Radio Corporation of America (RCA), is considered the father of the television because of his inventions, the picture tube and the iconoscope camera tube. The electronic engineers as a profession sprang from technological improvements in the telegraph industry during the late 19th century and in the radio and telephone industry during the early 20th century. Receiving and transmitting people gravitate to radio, attracted by the technical fascination it inspired, first in receiving and then in transmitting. Many who went into broadcasting in the 1920s had become amateurs in the period before World War One. In the World War II, the modern discipline of electronic engineering was to a large extent born out of telephone, radio, and television equipments. Development and the large amount of electronic system development during World War II of radar, sonar, communication system, and advanced munition and weapon systems. In 1940 to 1950, the word electronics began to be used the term electronic engineering. At the electronic laboratories created and subsidized by large corporations in the industries of radio, television, and telephone equipments, began churning out of a series of electronic advances. In 1948 came the transistor. In 1960 comes the integrated circuit which would revolutionize the electronic industry, and in the United Kingdom the subject of electronic engineers became distinct from electrical engineers as a university degree subject. Facilitate the development electronic engineering even before it acquires name facilitated the development of many technologies including wireless telegraphy, radio, television, radar, computers, and microprocessors.
History of telecommunications engineering. My name is Edison Gonzalez. I am a student of electronic engineering. Today I come to introduce you a little of the history of telecommunications engineering. This is the engineering that my college David studies. Before I begin, I will explain how the body of my slides is in general. The first thing is that I will explain what is currently a subject of telecommunications engineering. Later, develop the oldest history based on physics, later on development of electronic sister branch of telecommunications. Then talk about the advances purely in the area of telecommunications, and finally highlight the most important. So to take into account telecommunications engineering or telecoms engineering is an engineering discipline centered on electrical, electronic, and computer engineering, which seeks to support enhanced telecommunication systems. Telecommunications is a diverse field of engineering connected to electronic, civil, and engineering systems. During this slide, you can observe what should be the field of action of telecommunication engineering between the I mentioned provide telematic services, knowledge and control of network infrastructure, but its correct definition is given by one of the most important companies and which regulator telecommunication are worldwide. The definition given by the International Telecommunication Union (ITU) for telecommunication is any transmission and reception of signals, reading and imaging sounds and information of any nature by wire, radio, optical, or other electromagnetic systems. What are its branches? The branches are broadcasting, network infrastructure, telematics. These are some of the branches or applications or areas of applications. So next, the first things. As different civilizations began to spread over ever-growing territory, an organized system of communication was necessary to allow effective control of those territories. It is more than likely that the oldest telecommunication method is the one made with messengers. Messengers is the same marathons. People would travel long distances with their messages. I know that it's important to recognize the history of cultures as larger as the Egyptian and the Roman, but it was to be hoped that in the midst of the necessity they would create a way of communicating, whether it be smoke or another. So from here we go to enumerate the possible predecessors in Greek mythology, messaging on horseback, and smoke signals, telecommunications engineering, as conceived today, began with telegraphy. Since its inception, it has been deeply linked to signal electronics. So the next, starting from the physics, physics is very important. You can observe in the images located in the center of the slide. First, the equations of Maxwell. Second, the radiation of electromagnetic waves through antennas. And finally, a representation of the electromagnetic wave in the XY plane. This is in order to give the importance to the physical. Since the revolution in the telecommunication is due to the electrical and magnetic discoveries by great physicists and thinkers in the history. The physicists who influenced could be taken into account since Aristotle, Galileo, but if Maxwell and Hertz were the most outstanding by the end of the 18th century. Maxwell, who was able to unify the thoughts of many authors who preached atomic models or models of action at a distance, and that in some way or another were always influenced by religious thoughts, but always an end to understand the functioning of the universe. Hertz was influenced by Hermann von Helmholtz, would challenge him to check the equations of Maxwell. This realizing continuous experiments was able to radiate electromagnetic waves between two antennas of a room. After this, in 1896, Marconi managed to transmit and detect these waves, called Hertzian, and opened the way to such an important advance as television and telecommunication. The Bureau of Telecommunication is rooted in the constant advance in the area of electronics, as the branch of science can be located in 1895, the year in which Lorentz postulated the existence of charged particles called electrons, which was demonstrated experimentally by Thomson 2 years later. Brown in 1897 made public his invention of first electronic tube, the elementary predecessor of the cathode ray tubes that are part of televisions. So, evolution in electronics to evolve telecommunications. The dial. With the creation of thermo-ion bulb or dial by British physicist John Ambrose Fleming, what later became a dial shows the important property of conducting the current only when the voltage applied to it has a certain direction. In 1905, the American physicist Lee De Forest, perfecting the invention of Fleming, created the triode. Forest's contribution consisted of the introduction of a third element, the grid, near the cathode. The proximity between the cathode and the grid causes that if the latter is subject to a small voltage, it substantially influences the flow of electronics inside the tube. Therefore, the triode acts as an amplifier. Continue with evolution in electronics to evolve telecommunication. The invention of the aforementioned devices provide the technology basis for the rapid development of radio communications. For 1912 in the United States, an association of radio technicians was constituted. The first commercial radio station was also built there in 1920. In the 1920s and 1930s, improvements were made to the original electronic tubes, which culminated with the introduction of the pentode, increasing its flexibility and field of application. Among other things, the invention of television 1930 and of frequency modulation radio 1933 become possible. The final creation were integrated circuits in your advances to the transistor age. Without a doubt, the advance of the electronic in the middle of the 20th century was the transistor. In fact, this was considered as an electronic era with the commercialization of the transistor in 1951, laying the foundation for the qualitative and quantitative development of electronic technology in the second half of the century. The transistor provided the same functionality of the triode, being smaller, efficient, reliable, economical, and durable. This allowed the system of a range of the previously unthinkable application and the reduction of cost and the size of commonly used electronic devices, radio, television, among others. Advanced focused only on telecommunications, telegraph, and telephone. Samuel Morse independently developed a version of the electrical telegraph that they usefully demonstrated on 2 September 1837. Soon after, he was joined by Alfred Bailey, who developed the register, a telegraph terminal that integrated a logging device for recording messages to paper tape. In 1880, Bill and co-inventor Charles Sumner Tinter conducted the world's first wireless telephone called by modulated light beams projected by photons. The scientific principles of their invention would not be utilized for several decades, when they were first deployed in military and fiber optic communications. In the radio and television over several years, starting in 1894, the Italian inventor Guglielmo Marconi built the first complete, commercially successful wireless telegraphy system based on airborne electromagnetic waves radio transmissions. On March 25 years, mm, 1925, Scottish inventor John Logie Baird publicly demonstrated the transmission of mobile silhouette pictures at the London Department Store Selfridges. In October 1925, Baird was successful in obtaining moving pictures with half-phone series, which were famous across the press through television picture. This led to the public demonstration of the improved device on 26 January 1926 again at suffrages. Various first devices rely upon the nickel disc and thus become known as the mechanical television. It formed the basis of semi-experimental broadcast done by the British Broadcasting Corporation beginning September 30, 1929. Continue with advances focused only on telecommunications, satellite computing networks, and the internet or optical fiber. The first U.S. satellite to relay communication was Project Escort in 1958. In 1960, NASA launched an Echo satellite. On 11 September 1940, George Steptis was able to transmit problems using teleprinter to his complex number calculator in New York and received the computer results back at Dartmouth College in New Hampshire. ARPANET's development centered around the request for comment process and on 7 April 1969 was published. In September 1981, introduced the Internet Protocol version 4 and introducing the TCP, thus creating the TCP/IP protocol that much of the Internet relies upon today. In 1966, Charles Kyle and George Hauptmann proposed optical fibers at STC Laboratory STL at Harlow, England. So, in general, and making a timeline of advances in telecommunication, we can say that the vast majority occurred in the 20th century, and these are: 1. Development of the telegraph and telephone. 2. Radio and television. 3. The radar. 4. The development of communication satellites. 5. Maritime and aeronautical radio navigation systems. 6. The transition from black and white television to color television without loss of compatibility. 7. The digitization of telephone switching networks. 8. The development of mobile telephony. 9. The development of different global position systems. 10. The development of telematic networks of data communication between computers and the internet. 11. The development of IP television and others. In this moment, such as telematics and mobile telephony, in recent years, I'm talking about advantage of development in the field of computing. So, thank for you pay attention.